All right. Now, let me pose a challenge with this approach. Suppose the NIDS sees a packet with some data, and then it sees a reset packet. Now, according to the TCP spec, the reset packet, what a reset packet does is when it's received, it causes the recipient to tear down the connection. It's like a shutdown, like this connection is over, we're done, okay? My question to you, what should a NIDS do if it sees a reset packet on an existing connection? Okay, so I want you to think about what you think is the right thing for the NIDS to do. Option one is assume the reset packet will be received and like delete that connection from its connection table. Option two is assume the reset won't be received and keep the connection around. And option three is something else. So why don't you think about what you think would the right thing for the NIDS be to do, and then type in chat what you think the NIDS should do and why. Okay, might be safer to assume it won't be received. Why safer? Monitor the connection for an ACK. Well, that's an interesting idea. Unfortunately, reset packets, I think, are not ACKed. So you might not be able to tell whether the reset packet's been received, but maybe you could look for later packets and see if they do get ACKed. Check if there's a response packet afterwards. Yeah, reminds you of the attack on the firewall where we did this TTL game where the reset had a TTL that was set so that it would die before it reached the target, but would still be seen by the firewall. Same thing could happen here. Okay, so this is why it'd be safer to assume the reset is received, but it's hard to know for sure because of these TTL games, we don't actually know whether the reset will actually be received or not. So you might be inclined to say if you see a reset packet, then you should delete that connection from the table. And the reason for that would be to avoid keeping around memory, avoid using memory. You got to get rid of a connection at some point, otherwise the memory is going to grow forever. From a performance perspective, you'd really like to be able to delete connections when you see reset packets. But from a security perspective, it's dangerous because what if the attacker sent a reset packet but with a low TTL and it doesn't actually make it to the recipient? Then you need to remember that there's some state for this connection that you've seen the beginning of /etc/p. And if you later see a packet that follows ASSWD, like the remainder of this, then whoa, that's bad. There's been an attack that's happening. Okay, so from a security perspective, you sort of almost have to assume it won't be received. But then, great question. Oh my gosh, won't it be too much state to track? It might be. If every reset packet we see, we assume it won't be received, then we can somehow like maybe never, we might have these connections that get shut down by a reset and then we have to keep them forever. And that seems really painful. The amount of state is going to be just growing. And boy, it's really opening up an opportunity for denial of service attack, where attacker opens a connection, sends a reset packet, opens a connection, sends a reset packet, opens a connection, sends a reset packet. Each one is using up more and more memory in the NIDS, and the NIDS is going to run out of memory. And then what is it going to do? Maybe it can't detect any attacks, and the attacker has completely fooled you. So this is painful. It feels like there's no really good decision here. And maybe there's some kind of trade-offs you could work around where the connection, you wait for a certain timeout to see if there's any following data, and then after, if you see a reset packet, then and you don't see any following data for an hour, then eventually you time out that connection. But this is kind of hinting at we're in a difficult spot. Yeah, could the NIDS send its own reset packet to the recipient? That's a very clever solution. I like that a lot. That would work. That requires the NIDS to be active rather than merely passive and merely monitoring. So system administrators might get a little bit more scared by that, because now if it's purely passive, it really can't do much harm if something goes wrong. It might send you a false alert, but it's probably not going to trash your network. But if it becomes active and it can send reset packets, you better make sure that it's not erroneously sending reset packets, or you're going to have hard to diagnose network problems. But that's a viable strategy. Yeah, yeah, yeah. So yes, just in summary, it seems like there is no really good answer. If we assume the reset will be received, that's insecure. We might miss attacks. If we assume the reset won't be received, it might consume too much memory, too much state, and we might be susceptible to denial of service attacks that could in turn be used to cloak an attack. So no matter which we do, we might be exploitable.